Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of rectangles in step 4. This is a very difficult one. If you can master a prediction for step 4, can you predict for step 43? And could you write an equation that could be used to predict the number of rectangles in any step at all? That is the challenge. If you'd like to accept it, pause the video and see what you can do. Okay, so this one clearly is getting big really rapidly. So definitely not going to be a linear equation. Maybe quadratic, maybe something even bigger with faster growth than a quadratic. I'm seeing this sort of interesting star shape here. Let's see, there are 4 on the top half and 4 on the bottom. And then it looks like the arms of the star start to grow. Let's see if I can sort this out. Yeah, it looks like we add 2 there, we add 2 there, we add 2 there, and we add 2 there. And then what happens next? There's the first 2. So it looks like we add 4 and 4 and 4 and 4. So we have our original kind of star shape at the beginning, then we add 2 on each arm, then we add 4 on each arm, that doubles. So I'm thinking we would add 8 on each arm for the next one. So we would have 8 more here, and 8 more here, 8 more here, and 8 more here. So that's my prediction for step 3. What would that be? Let's see, there's the original 8, and then we added 8 more, so that was 16. And then we added 16 more, so that's 32. And then we're adding 4 times 8, 32 more. So that would be 64 for step 4. So let's take a minute to analyze these numbers. So I'm going to make a chart with the step number and the number of rectangles. So in step 1, we have 8. In step 2, we added 8 more, so that was 16. In step 3, added 16 more, so that was 32. And then we're saying 64 for step 4. Well, what do you think? Are you noticing anything with the numbers here? Have you got an idea about what kind of a pattern this might be? Let's try taking the differences, because that's what we usually do. 16 minus 8 is 8, 32 minus 16 is 16, and 64 minus 32 is 32. And we didn't get a constant, we got a pattern actually that repeats up here. Let's try that again. 16 minus 8 is 8, and 32 minus 16 is 16, and we're actually repeating the same pattern. This is something that happens with an exponential equation, some number to the x power. To determine what that number is that's being raised to the x power is you take a look at what's happening between each step. Is it doubling, tripling, quadrupling? If it's doubling, it's 2 to the x. If it's quadrupling, it's 3 to the x. So let's see here. Yeah, 8 is, you double that, you get 16. Double 16, you get 32. Double 32, you get 64. So this looks like our stem here is 2 to the x. But if x is the step number, this doesn't match what's up here, right? 2 to the first power is 2, not 8. And 2 to the second power is 4, not 16. Now, I could actually think about this in one of 2 ways. You can think about a multiplier, right? So if this is 2 to the first power, what would I multiply it by to get 8? Well, that would be 4. So I could call this 4 times 2 to the x. Let's see if that works for the other ones. In step 2, that would be 2 squared times 4. That'd be 4 times 4, that's 16. In step 3, that'd be 2 to the third times 4. 2 to the third is 8, times 4 is 32. So that appears to work. Another way to think about this is to change what's up here in the power. This equation actually is the exact same thing as saying 2 to the x plus 2. So thinking about how that works, in step 1, I'd have 2 to the 1 plus 2 power. 2 to the third power is 8. In step 2, I'd have 2 to the 2 plus 2 power, that's 2 to the fourth, that's 16. These expressions are really identical because that 4 is a 2 and a 2. We're multiplying it by 2 more 2's, so that's the same thing. I'm going to leave it with this multiplier. So I'm going to write my equation as y equals 4 times 2 to the x power. Now, to calculate how many in step 43, we just need to punch in on our calculator 2 to the 43rd power and then multiply it by 4. You're definitely going to want a calculator for that. I got, let's see, 35 trillion, 184 billion, 372 million, 88,832. That's how many rectangles in step 43 if this pattern keeps growing in the same way. Well, how did that go for you? We haven't seen an exponential equation in a long time. Did you get 64 for step 4? I think it's tricky to get that step 4 right. Did you come up with an exponential equation? Let me know. Thanks, everybody.